Okay, notes on solving systems of linear equations by graphing. Your objective. Solve a system of linear equations by graphing both equations on a coordinate plane and determining at which point they intersect. So we're not solving equations with just one variable. Now we're solving equations with two. And a system of linear equations is two or more equations that provide a solution, which means numbers, a solution for both the x and y coordinates. So we're going to figure out what x and y are by solving both of these equations using graphing. So, when you graph two linear equations on the graph, the common point where they intersect is a solution for both equations. So unless you have two equations that have the same slope, which means they're parallel, if you have y and x, you know they're going to be diagonal, and they will at some point intersect. So we just have to graph these and find out where. So the first one, it's in slope-intercept form. So let's find our y-intercept, which is 4. And our slope is 4, so up 4 and over 1. When you graph, you need to make sure that you're very exact. So you have to use a straight edge. So, right there, through that, and you can extend it in both directions. Okay, next equation. Let's do our same change opposite. So we know in this case, our y-intercept is -2, so right there on the y-axis, and our slope is 2, so up 2 and over 1, up 2 and over 1. Okay, let's graph that one. And you can see they intersect right there, down in the third quadrant, and it looks like our point of intersection is right here. So now figure out the x and y coordinates. So I went over -3, and I went down -8. Now, to check that, we need to take our solution and substitute it back into either of these equations. So let's use this one. So y is -8, which equals 2 times x is -3, and then plus -2. So I have -8 equals -6 plus -2. So does -8 equal -8? It sure does. So check. That's a solution for both equations. Let's try another one. Let's do our same change opposite here. So we know that -3 is our y-intercept right there, and our slope is 1/3, so up 1 and over 3, up 1 and over 3. So let's go ahead and graph this one. And again, extend it in both directions, basically as far as you can go. Okay, let's look at our other equation, y equals -x plus 1. Our y-intercept is +1, so right here. And our slope is -1, so -1 over 1, so that's up 1, but to the left 1, up 1 to the left 1. Okay, let's graph that one. And you can see it intersects right at that point. So what is this point? It's over 3 and down -2. So now let's check. Remember how? We substitute the x and y into one of the equations. Well, I don't like the fraction one, so let's substitute it in this one. So y is -2, which equals x is negative, and then I have a 3. Plus 1. So -2 equals -3 plus 1 is -2, which of course is true. So 3, -2 is a solution to both of these equations. Okay, what's different about this system of equations? You have -4x plus y equals 3, and y equals -x minus 2. Well, from class, you know from our warm-ups that we were learning to put these in slope-intercept. So in order to graph this, I need to do that over here. So one of the equations isn't in slope-intercept form, so you will need to change it before graphing. So let's go ahead and take our negative 4x plus y equals 3. And let's isolate or get the y by itself. So we need to get rid of that negative 4x. Okay, so we're going to highlight that. That's what has to move. So the opposite of negative 4x is positive 4x. They cancel because they're opposite, so I'm left with y equals. Remember, that's a number term. This is a variable term, so you can't combine them. So I have 4x plus 3. Now it's in slope-intercept form, ready for graphing. So our y-intercept is 3. And our slope is 4, so up 4. 1, 2, 3, 4. And over 1. And if you want, you can go down 4 and in the opposite direction, so you have 3 points. Go ahead and graph that. And again, remember, you have to be pretty exact on your graphing. So use a good straight edge and use graph paper. Okay, the other one, I have a minus. Let's do our same change opposite. So in this one, our y-intercept is negative 2, and our slope is negative 1. So that's up 1 and over to the left. Well, look at that. It already matches on that line. So we don't really need to draw the line. We know it crosses right at that point which they both shared. So what is that point? It's over negative 1 for the x. Right here, over negative 1 and down negative 1. Okay, let's check it. Let's go ahead and substitute it into this equation. So I have negative 4, and my x this time is negative 1, plus my y is negative 1, and that equals 3. Well, negative 4 times negative 1 is positive 4. 4 plus negative 1 equals 3. 4 plus negative 1 is negative 3, or is positive 3, excuse me. So 3 equals 3. So you can check it. So this is a solution to that system of equations. So let's recap real quick. Our steps for solving a system of equations by graphing are: change into slope-intercept form, graph both equations, determine the coordinates of the point where they intersect, and check by substituting the x and y coordinates back into one of the equations. Okay, pretty easy. Well, if I look at both these, neither of these is in slope-intercept form. So let's go ahead and do our same change opposite there. And let's get the y by itself. So x plus negative 9. So I'm multiplying by 3, so I have to divide everything by 3 on this side. They cancel, so there's my y by itself. So we know that's a 1 there, so my slope is 1/3 x. Negative 9 divided by 3 is negative 3. So that one's done. Let's go ahead and graph it. So the y-intercept is negative 3, and our slope is 1/3. So up 1 over 3, up 1 over 3. Extend your line, because you never know where it's going to intersect. And let's work on the next one. 2y plus 2x equals 2. So I need to get the y by itself. So in this case, we know we have to get rid of the 2 in front, and we have to get rid of the 2x. So it helps to highlight so you know what to move. So we're going to deal with this part first. The opposite of 2x is negative 2x. They cancel, so I'm left with 2y equals negative 2x plus 2. And now, just like this problem over here, I have a number in front of the y, so I have to divide by that number. That means I have to divide every term by that number. So that cancels, so I'm left with y equals negative 2 divided by 2 is negative 1x, and 2 divided by 2 is 1. So that's in slope-intercept form, so now we can graph it. So I have the 1 there for my y-intercept. And then my slope is negative 1, so that's up 1, but to the left 1. Up 1 to the left 1. Okay, let's graph it. And you can see where it intersects the other line. So the solution to this would be right here. So that's over 3. and down negative 2. So now let's check it. Let's substitute it into this equation right there. So y was negative 2, so put that where the y is. Okay, x was positive 3, then that equals 2. So 2 times negative 2 is negative 4. 2 times 3 is 6, which equals 2. Negative 4 plus 6 is 2. So 2 equals 2. Check. That's a good solution. Fairly easy. There's just one question. When do you think this method might not work so well? So we kind of discussed it in class a little bit. What would happen if when they intersected, let's take this for example, they intersected at a place that wasn't an integer. So like right here, we would not know how far over on the x or how far down on the y. So we're going to learn tomorrow how to do this mathematically so that we don't have the graphing problem in this case. So now the next video will be on solving some of these 5 questions from your practice notes. Okay, good work.